Hello everyone, welcome back to our lecture series. Emeka Udenze is speaking once again. Today we'll be talking about Amines nomenclature. So the basic thing we're going to be discussing in this lecture is the nomenclature of amines. Let's take it off from there immediately. Here I have a beautiful quote for you from a renowned Nigerian American author who writes a lot. She is a champion of women's rights and gender equality, and has written a lot of novels. Let's hear what she has to say. In fact, she's known for this quote came from one of the most watched TED Talk series, where she talked about the dangers of a single story. Let's hear what she has to say. She says, "Many stories matter. Stories have been used to dispossess and to malign, but stories can also be used to empower and to humanize. Stories can break the dignity of a people, but stories can also repair that broken dignity." I don't have much to say with this. Chimamanda Ngozi Adichie has already spoken to us. This is a food for thought. All right, let's immediately start our lecture. The two main learning objectives we intend to cover in this lecture are: number one, we're going to classify amines as primary, secondary, and tertiary amines. And then we know how to name amines using the IUPAC and a bit of the old nomenclature as well. I think I should have included that. And we're going to also try some old nomenclature, because some of them, particularly the small molecular weight ones, you do them with the old nomenclature. And then we now also know how to draw the structural formula. So these are the two things we're going to be covering in this lecture. Let's immediately take it off from there. Amines. What are amines? Amines are derivative of ammonia. They are derivative of ammonia where one or more hydrogen atoms have been replaced by an alkyl or an aromatic or phenyl group. Alkyl, it can be called an aromatic, a phenyl, or maybe an aryl group. It doesn't matter, anyone you call it. So that's the commonest way to define it, particularly to make it highly simplistic. Now, this is the structure of ammonia. This is the structure of ammonia. That's what I have here. This is the Lewis structure of ammonia. This is the Lewis structure of ammonia that I have here. Now, you see, ammonia has remember, nitrogen will always have 3 bonds and 2 lone pairs. That's why you see the lone pair there. Now, when one of these hydrogens have been replaced by either an aro group, which is a long chain alkyl group, or an array group, that means a benzene connection. It can be an aromatic benzene. What we say is that you formed an amine. Let's see an example here. Now look at what I have here. Now, if I replace, let me use a different color. So if I replace this guy with R, okay, not that one. That's not the one I replaced. If I replace this one with R, I form an amine. Whereas this is ammonia, this compound will be a general formula of a primary amine. So this is an amine. What I simply did was to replace one of the hydrogens. So if you replace this one too and put another R here, this is also an amine. And you can also replace the 3 hydrogens, is also going to give you an amine. We're going to know what's the difference when you have either 2 R's or 1 R or 3 R's. We're going to see where that plays an important role. So nitrogen containing compounds are abundant in nature. There are so many of them. They are commonly found in medicines. Many medicines or drugs are derivative of amines. They also find in amino acid. They first look at the name amino. That means it has an amino group, and of course acid, the carboxylic group. They're found in proteins, in enzymes, and neurotransmitters. Neurotransmitters are chemical messengers in the synapses that helps in transferring impulses. And then they're also found in nucleic acid. The nitrogenous bases are amines as well. So they're very common in biological systems. Let's now go to that classification of amines. Of course, classification of amines is one of our important objectives in this class. Now, amines are classified either as primary, secondary, or tertiary amines. Now, the one I showed you earlier, remember this picture I showed you? I told you this is a primary amine. Why is it a primary amine? We're going to see the reason why. A primary amine has either has 1 aro group. Then remember the R could be an alkyl group or an aromatic group. So it has one R group, or you can say it has two hydrogens attached to the nitrogen. Remember, the attachment must be to the nitrogen. A good example is this one here. Only methyl is the R group we have here. And what do we have here? What do you see? Methylamine. Of course, this is the old name, but we're going to talk about that much later. So this is an example of methylamine, one R group. So this is a primary amine. Now, a secondary amine, what about it? A secondary amine will have two R groups. Now look at it. There's an R group here, an R group here. Or you can say a secondary amine would have two R groups or one hydrogen attached to the nitrogen. So if either has one hydrogen, or if you say two R groups, whichever definition that helps you to define it as a secondary is okay. And a good example here is that if you look at it, this is an amine, this is an R group, another R group, specifically methyl group. This is dimethylamine. So dimethylamine is an example of what? Secondary amine. Now, what about a tertiary amine? A tertiary amine does not have a hydrogen because all the hydrogen has been substituted by R group. Look at it. There's an R group here, there's an R group here, and there's an R group here. There's no hydrogen. What it means is that all those hydrogen have all been replaced by an alkyl or aromatic group. In that case, we say that is what? A tertiary amine. And a good example here is this methyl group, and there are three methyl groups. That's why to name this, we say it is trimethylamine. Three methyl group attached to the nitrogen. So these are the three classes of amines. We now go to also the classes. Remember, the amines can also, like I told you earlier, when the R group is an aromatic group, it becomes an aromatic amine. So in looking at the classes of amines as well, amines can be classified either as aliphatic or aromatic amine. In aliphatic amine, all carbons are bonded to the nitrogen are derived from the alkyl groups. When you have the open chain alkyl group that is not an aromatic group, we say is aliphatic, like we saw in the previous page. Remember, in the previous page, all these groups, all these three classes I showed you here, with the examples I showed you, are all what? They are all aliphatic amine because there is no aromatic group attached to this nitrogen. However, when you go back now, I have some other examples. So in the aromatic amines, one or more groups, either one or more of the groups attached to the nitrogen must be an aryl or benzene or aromatic group. So, and in fact, most importantly, all of them are built up from the aniline. Aniline is the simplest aromatic amine. Simplest aromatic amine actually is the simplest aromatic amine. And it is a primary amine. Let's look at what. So here, this is the benzene ring. The benzene ring is connected to the nitrogen. Remember, the nitrogen has what? Two hydrogen, therefore it's a primary. It's a primary amine. And a primary amine, this is aniline. Remember, we covered aniline when we talked about unsaturated carbons, particularly in aromatics. Now, when one of these hydrogen is replaced, in this case, replaced by this, so you now have two attached groups to the nitrogen. You have an aromatic group here and an alkyl group here. Only one hydrogen is what it has here. It has only one hydrogen. And when it has only one hydrogen, it is what? A secondary aromatic amine. And this one can be named as N-methyl-aniline because this methyl group is attached to nitrogen. We have to show that nitrogen. And there is a methyl group, N-methyl, and it's built from aniline. We call it aniline. So this is N-methyl-aniline. We're going to talk about the nomenclature just immediately after this. Now, in this one now, you look at it. It doesn't have a hydrogen on the nitrogen. Methyl group, and aromatic group. There's no hydrogen. This is a tertiary aromatic amine. And to name this, there are two methyl groups attached to the nitrogen. We say it is N, dimethyl-aniline. Now, every aromatic amine must be named from aniline. That's why you see all of them end with aniline, which is their simplest or their parent compound, so to say. All right, we now go to the next thing, nomenclature. Now, we'll look at the nomenclature, like I said when I was talking about the objectives. We're going to look at the common names. We're going to look at the IUPAC nomenclature. So the common names are used extensively for amines with low molecular weights, just amines that have like ethyl and methyl groups that are easy to name. That's what we use them mainly. Now, what are the steps? The steps are simple. Alphabetically link the names of the alkyl or the aromatic groups attached to the nitrogen. You always have a nitrogen that has an attachment of either a hydrogen or a methyl or alkyl group. So alphabetize it and put the word amine at the end of it. So attach the suffix amine so that the name becomes one word. And then you use the word di, tri, or tetra when identical alkyl groups are attached. So that means there's more than one of them. You have to use, if it is 2 methyl groups, you say tri-methyl. 2 methyl groups, dimethyl. 3 methyl groups, trimethyl. That's the difference. Let's run through some examples here. So now, in the old name, we're going to know this is methyl group attached to the nitrogen. So you just say methyl amine. You just put the name. Their last name in the common nomenclature is the amine we have here. Just say methylamine. That's how you name this. Now, this one has 2 attachments. This is a primary, of course. This is a primary amine. Now, this one has 2 attachments, 1 hydrogen. So this will be a secondary. Look at what you do. You now put the names of this attachment, the names of the attached groups. You have methyl group here and a methyl group. And they are the same. You not say methylamine. You just say dimethyl, because there are 2 of them. Dimethylamine. That's how we name this one. And coming to name this one now, this one has 2 different groups. Remember here, there are 2 of them of the same alkyl group. Here, there are 2 different alkyl groups. This is, of course, is methyl. And this is what? This is ethyl. So what do you see? Attached on both sides. So now, we're going to use alphabet to know the one that comes first. Ethyl is E. Methyl is M. So E comes first. So we're going to say ethyl, put this one, no space. Ethyl, put this one. You put ethyl, no space. Methyl, amine. That's what you say. Ethyl, methyl, amine. That is how you name this. So we're going to be going straight to our reflection questions to practice this nomenclature after we talk about the IUPAC nomenclature rules. So in IUPAC nomenclature, almost the same rules apply. Of course, the functional group here is the nitrogen, attached to the nitrogen. So we're going to give it the priority. So in the IUPAC nomenclature, I have 4 rules we're going to go through. Number 1, you determine the root name of the longest chain. Of course, the root name is usually met, et, prop, but, pent, hept, I didn't say hex, oct, nona, dec. So you determine the root name first. And then the name of you're going to change the E ending the alkane group to amine, amine. So look at what I'm saying. Now, if you have a 10, what are you going to do? You're going to be removing this, and you're going to be putting what? Amine. It's going to be a 10 amine. That's what it's trying to tell you. That is what we're going to do in this case. And then you position the position of the carbon that has the amino group. A carbon, the nitrogen or the amino group is attached to a carbon. So the carbon that has the amino group must be numbered and gets the lowest numbering possible. As usual, in IUPAC name, we always want to give the functional group the lowest number possible. So now the numbers are also used to locate other attachment. You have to locate other attachment on the carbon chain. You have to locate every other attachment on the carbon chain and then say where they are located. Now, italic is used. Now, when the attachment is on the nitrogen, because how do you name the nitrogen? You just say N. So italic capital N is used as a prefix for attachment on the nitrogen atom. So if there's an attachment not on the carbon, this time on the nitrogen, you have to say it is N. N-methyl, N-ethyl, depending on what the alkyl group is. And finally, amines that have 2 or 3 nitrogens are named as either diamines or triamines. So you have to, so at the end of the name, you have to put diamine or triamine. If it is 4, tetraamine, and as it goes. So let's see these 2 I have here. I already have the name. So this is an amine now. Of course, this is a functional group. What it means is that this other thing is going to be our attachment. So if you counted from here, 1, 2, 3, 4, 1, 2, 3, 4, this becomes what? 4. You can't count from here because this is the functional group. This is not a functional class. This is an attachment. Nitro is an attachment. So we're going to count from here. 1, 2, 3, 4, 5. The longest chain is pentane. If it is pentane, so we're going to say pentane. We're going to remove the E and put amine. However, where is this located? This is located in carbon number 4. And it's nitro. So we're going to say 4 nitro pentane amine. That is why we have this name. 4 nitro. And then, oh, okay, the space here, I didn't have enough space, but I named it already, so no need to bother about that anyways. So it's going to be 4 nitro. The amino group is located in carbon number 2, so it's going to be 2 pentane amine. The same thing we're going to do with this one as well. In naming this one, what are we going to do? The same thing. We'll count the longest chain. The longest chain, of course, is going to be from 1, 2, 3, 4. It can't be this one. This is 1. 1, 2, 3, 4. What it means is that this is an attachment, but this attachment is on the nitrogen. And this attachment is methyl group. Remember, this attachment is methyl group on the nitrogen. So we're going to name it as N attachment. Now, where is the nitrogen located? It's located in carbon number 1. And it is 4. So it's going to be 1 butane amine. And where is the methyl located? Methyl is located on nitrogen. So we're going to say N is usually italicized. N methyl 1 butane amine. N methyl 1 butane amine. That is how we name it. So quickly, let's take some examples. Okay, let's see what happens here. Now, to name this one quickly, we're going to count the longest continuous chain. So to count it, this is going to be 1. I'm going to use my red as usual. Prefer using that. This is 1, 2, 3, 4. Because if I count from here, 1, 2, 3 gives it 3, I can't go. So this is the correct counting. My amino group is located in carbon number 2, and the longest chain is butane. There's no attachment, so we're going to name it 3. So this is going to be in 2. So it's going to be 2 but. 4 means but. Butane. We're going to remove the E and put amine. So this is 2 butane amine. That is how you name this. Now, to name this one, let's see this one now. Let's go to this one and name it. To name this one, again, you count the nitrogen is located here, so this will give it a lower counting from here. If you count from here, it's going to be fast. So we're going to say 1, 2, 3, 4, 5. This is pentane amine, and it's a carbon number 2, so it's going to be 2 pentane amine. Now, does it have no attachment on the carbon chain, but there's an attachment here, which is methyl group on the nitrogen. So only that attachment. So what are we going to say? We're going to say it's located in the N. So we're going to say N methyl. Remember, you have to put the attachment first in IUPAC nomenclature. N methyl followed by, what is the longest chain? Is pentane. But where is the amino group located? In carbon number 2. So it's going to be 2. Remember, anytime you separate a letter and a number by hyphen. So it's going to be 2 pentane. 5 is pentane. You're going to remove here. Put it there is wrong. So remember, you have to remove it. And then you put your what? Amine. So that is how you name that guy. Now let's go and name this one. So for this one again, we count. This one is going to be 1. Here, if you count from here, this is going to be fast. So I'm going to count from here. 1, 2, 3, 4, 5, and 6. So this is hexane amine. But the amino group is located in carbon number 1. So it's going to be 1 hexane amine. I don't want to write this for you because I want to conserve the space. Okay, I can do that. I can just say. So I can put my 1 hexane amine here. 1 hexane amine. Yeah, that's what I have at the end because this is 1 hexane amine. And then, what is located? Bromine and methyl. Which one comes first? B comes before M. So it's going to be 4 bromo. Carbon number 4. Methyl group is in number 3. 3 methyl. Okay, you see, that's why I don't like writing it first. I know I can make it very big. So I'm going to shift it a little bit. It's correct, it's just I want to make space. So I'm going to say 4 bromo. 4 bromo in carbon number 4. 3 methyl 1. Remember, this is 1 hexane amine. 4 bromo, 3 methyl, 1 hexane amine. That is how we name this guy. Now, in naming this one now, let's name this one quickly. In this one now, let's see. Again, if you count from here, it's going to give this nitrogen long numbering. So we have to start counting from here. 1, 2, 3, 4, 5, and 6. So still this is hexenamine. But now it's also located in carbon number 1. Now, but there are attachments. What attachment do we have? We have chlorine and methyl group attached to the nitrogen. And we have methyl here attached number 3. So now what do we name first? Chloro will come first. Where is chloro located? It's located in N. So we're going to say N chloro. After N chloro, what else do we say? N chloro. The rest is the same thing. Methyl group and this is the same thing. So where are they located? We can say now here one is located in N and what? In number 3. You put it. Remember, this will be N. As is an italicized number, is an italic N. So usually when you see this kind of problem, the alphabet comes first before the numerical number. So we're going to say N, comma 3 is located in carbon number 3 here. Remember, N, comma 3, and there are 2 of them. It's going to be di. Let me write that D very well. It's going to be dimethyl. Then amino group is located in carbon number 1, 1 hexane amine. That is how we name that. N-chloro, N3 dimethyl, 1 hexane amine. Always feel free to pause this, try them out yourself, and always come back and check for comprehension. We now take the next reflection question. Now, before we do that, let's talk about a little bit of aromatic amine. I know I've already made a few comments about them. So, aromatic amines are compounds that are derived from aniline. So they are named as substituted anilines. All their names must end in aniline. So aniline is their simplest, is the simplest aromatic amine. Or you can say it's the parent compound. It's the parent compound of the group. Whichever way you want to put it. It's the parent compound of the group. Now, italic N is also used to indicate that an alkyl group is attached at the nitrogen, just like we did for aliphatic ones. If anything is attached at the nitrogen, you have to also say as N. So this is aniline, the simplest one. In this case now, look at this one. This is aniline, very easy. You have to memorize aniline. We talked about this when we did unsaturated hydrocarbons. Now, for this one, there's an attachment here, which is the methyl group. And there's an attachment here. This attachment 1, 2 is what? Ethyl. So which one will come first? E comes before M. So what are you going to say? Remember, it's going to be, this is, if you want to count, to give this the lowest number, it has to be 1, 2, 3, 4, 5, 6. So it's going to be in carbon number 3. So it's going to be 3 ethyl. Methyl group is located in nitrogen. It's going to be N-methyl. Then their parent compound is what? Aniline. This becomes the IUPAC name. All right. So we now take more examples. In reflection 2 here, it says, name the following amines. Let's also name this following amine. Now let's start from this one. Remember, this is an aniline that has a hydrogen. It has a nitrogen. So what it means, this has to be named as an substituted aniline. Let's count. If you count from here, 1, 2, 3, 4, 1, 2, 3, 4, it doesn't matter. So this is 1, 2, 3, 4. So the nitro groups is in carbon number 4, right? However, we have 2 methyl groups that are attached to this N. So nitro and methyl, which one comes first? M comes first. So it's going to be, it's 2 of them. You're going to say N, comma N, dimethyl, N, comma N, dimethyl. Where is this located? This is located in carbon number 4. See? 4 nitro. Of course, this is a nitro. Remember that. 4 nitro aniline. Remember, all of them must end with aniline because aniline is their parent compound. Let's name this one. This one might be a little bit tricky. Let's see how that is named. For this one, now if you look at this, you find out that you have a long chain here that has a phenyl group. Remember, whenever benzene is an attachment, we call it the phenyl. So what it means is that if you count from, let's count. If you count from here, 1, 2, 3, you you give it number 3. But if you count from here, 1, give it 1, 1, 2. So we're going to count this way. Because whichever way you count, this is in number 2. So I'm going to count from here. It's going to be 1, 2, and 3. Yes, that's what I'm going to do. So I'm giving it number 1. So it's going to be, and that's the only attachment we have there. So it's going to be 1 phenyl. Then this is in carbon number 2. Amine group. So it's going to be 2. The longest chain is 1, 2, 3. Propenamine. So it's going to be 2 propenamine. That is how we named that guy. Now, what about this one? This is what about this one? This is a cyclo. Remember, this is cyclopentane. So what you just say is say cyclopentane and put amine. So this is called cyclopentane. No, you have to remove the E. Amine. Yeah, that's how we name that. All right. And the last one here we do have here is a diamine. Remember what I told you? When you have 2 of these amino group attached, it has to be what? You have to say di or tri. That's exactly what you need to do. Okay, so what are we going to do? Now see. Now, we're going to name it. If you name from here 1, 2, 3, 4, this will give you 4, 5, 6, 7. That 4 and 6, that's 2 more. So we're going to count from here. This is 1, 2, 3, 4, 5, 6. The longest chain is 6, which is okay. The amine groups are in carbon number 1 and carbon number 3. So what are we going to say? No other attachment. It's just, it doesn't have attachment. It's just only the functional group. So look at that in 1 and 3. So we're going to say 1, 3. The longest chain is what? Hexane, 6. Hexane. No, you're going to remove this. Okay. Now, when you have a diamine, because D is a consonant, you're going to leave the E here. It agrees. So it's going to be hexane di, because 2 of them, amine. Remember, in all these ones, we left the C, we left the E. The E was not there. But in this case, because of this D, you're going to be leaving, whenever you have a diamine or triamine, because the T and D are consonant, you leave the E there. That is how these ones are named. Now, always feel free to pause this video, try out these problems yourself, come back and see how I did that and check for comprehension. All right, let us take the next reflection question. In this case now, we have the compound. Now we have the name, IUPAC name. Now we're going to draw. And it also says we should provide an additional name. So this one says, this is the old name, tet-butyl ethylamine. In the old name, you just put the N group at the middle. Remember, the nitrogen group will be at the middle. Tet-butyl, you attach it. So I'm going to attach it to the left. So this is going to be, tet-butyl is usually the Christmas light, remember. This is tet-butyl. Then ethyl, I'll connect it from here. My ethyl is going to be 1, 2, 1, 2. So this is tet-butyl ethylamine. This is the old name. You say provide another name. To provide another name, which is the IUPAC name, what do? We're going to first of all count and see the longest chain. What is the longest chain here? This is 1, 2. This is 1, 2, 3. Oh, these are our longest chain. So this is 1, 2, and 3 is my longest chain. If 1, 2, and 3 is my longest chain, which is propane. So this is propenamine. And nitrogen is located in carbon number 2. What it means is that this is an attachment then. This is an attachment, and this attachment is ethyl. So to name it again, what am I going to say? Let's see. I'm going to start with attachment. Oh, there's another attachment. This is also an attachment. Look at an attachment again. This is an attachment, metal, in carbon number 2. So first of all, let me write what the end. So the longest chain is propane. So it's going to be propanamine. Longest chain. Remember, where is amine located? In carbon number 2. So it's going to be 2-propanamine. That's what we have here. And then, what are the attachments? Ethyl in N and metal in carbon number 2. So E comes first. So we're going to say N-ethyl. N-ethyl. That's what we have here. And then metal is located in carbon number 2. So it's going to be 2-methyl. Oh, no, not enough space. Okay, I'm gonna try to give myself enough space there. Okay, so this will be, I have this already. So I'm gonna say N-ethyl, 2 is in carbon number 2. 2-methyl, 2-propanamine. That's another name for this. N-ethyl, 2-methyl, 2-propanamine. That is how we name that guy. Now we go to this one. This one is 2-chloro, N-propyl, 1-hexenamine. All right. So this is a hexenamine. So I'm gonna first of all put the hexenamine, and it is 1. The nitrogen is in carbon number 1. So I'm gonna say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm gonna put my nitrogen here. So if I number this, is gonna be 1, 2, 3, 4, 5, 6. That is okay. That is the name. That is the longest chain. I have it there, and it is in number 1. Now, what are the attachments? 2-chloro. Chlorine is located in number what? 2. So I'm going to say 2-chloro. Propyl is located in N. So I'm going to put propyl is 3 carbon. I'm going to put 1, 2, and 3. Yes. 1. So if I just use another color here, this will be 1, 2, and 3. This is propyl. And then, of course, you have to complete, because this is a tertiary amine, you have to complete your hydrogen here. This is how you draw the structure. So this is 2-chloro, N-propyl, 1-hexenamine. 1, 2, 3. 1, 2, 3, 4, 5, 6. Yeah, that is very correct. We now go to the last thing we have here. Still the same thing. We have the IUPAC names. Now we're going to also draw them again. We're going to draw this one. So again, let's do it. Now the longest chain is 2-octanamine. Octanamine, you have the amine group in number 2. So I'm going to do that first. 1, 2, 3, 4, 5, 6, 7, 8. That's what I have here. So if I number again, I always like numbering first. 1, 2, 3, 4, 5, 6, 7, 8. Now the nitrogen is in carbon number 2. I'm going to put it there. So this is, yeah. Now, so 2-octanamine. And I go, it says N-bromo. Oh, bromine is attached here. I'm going to put the bromine here. N-bromo. N-ethyl. The ethyl is still here, so I'm going to put the ethyl here. 1, 2. N-bromo. N-bromo. N-ethyl. 3-methyl. Where's the methyl group is in carbon number 3, so I'm going to put it up here. Okay, I'm going to try to take this off so that my methyl group is long enough. So this will be, yes. So this is, let's come, N-bromo, N-ethyl, 3-methyl octanamine. That is how we name this guy. And now the last but not the least of them we're going to name is the one that has aniline, right? Derived from aniline. So it says 2-ethyl N-methyl aniline. Let's first of all draw that. So I'm going to draw the benzene ring. I'm going to use the shortcut, of course. And then it says, I'm going to put this here, put the nitrogen. It says 2-ethyl, so this is going to be carbon number 1. So it's going to be 1, 2. So I'm going to say 1 and 2 here. So I'm going to put this. This is 1, 2. This is ethyl. Then 2-ethyl N-methyl. The methyl group is in the nitrogen. So I'm going to put it here. You can just say dash or you put it complete, doesn't matter. And then remember, you have to complete your hydrogen. So this becomes the structure of 2-ethyl N-methyl aniline. This is how you draw this structure. And having said that, we've come to the end of this lecture. Thank you for listening. Bye.